Hi everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 2 in a session October-November 2018, Paper 2-3. So let's start with the first question. Question number 1, solve the equation. So let me, when we open it, this is plus minus, so taking scaling on both sides. Okay, so we have a square of x 5x minus 3 whole square equals to negative 3x plus 13 whole square. Right, let me open the square. This is 25x square, 3 square is 9 minus 2ab. So negative 2 times 5 times 3, negative 30x equals to 3 square is 9x square, 13 square is 169, yes, plus 169, and 2ab is again negative 2 times 3 times 13 is minus 78x. Shifting all the terms to the left side, 25x square minus 9x square minus 30x and plus 78x plus 9 minus 169 equals to 0. Okay, so 25 take away 9 is 16x square, and 78 subtract 30 is 48x, and 9 subtract 169 is minus 160. Dividing by 16, right? So 16 times 1 is 16, we have x square, and 48 divides 16 is 3 plus 3x minus 160 divides 16 is 10. Yes, minus 10 equals to 0. Now let me factorize this. This is a quadratic equation, so if I can say that the factors are 1 times 10 is 10, 2 times 5 is 10, we can say 2 times 5 is 10, and 5 minus 2 is 3. Okay, let me break the note down. Alright, so we can say we have x square plus 5x minus 2x minus 10 equals to 0, right? Okay, x is common, x plus 5 is left, negative 2 is common, x plus 5 is left, equals to 0. So the two factors are x plus 5 and x minus 2. This is equals to 0. So we have two values for x. X is equals to 2 or x is equals to negative of 5. These are the two solutions. Question number 2, on each of the Venn diagrams below, shade the region indicated. Now the first one is A union B union C complement. So A, B, C. This is A union B union C, and complement is the outer region, right? Let me shade the region. The region that is outside the three sets. So this is a shaded region. Now for the second, A intersection B, this is a set A, and inside of set A there is a set B and a set C. Okay, A, its intersection with the set B, so this is whole B, and its intersection with C complement, that is outside of C, is this region, just the set B excluding the C. So this is going to be the shaded region. It looked like a disc. Right. Now for part 3, A intersection B. So this is a set A, this is a set B, and its intersection, A intersection B, is this, and its union with C complement, the region that is outside of C, all the region that is outside of C. So intersection, A intersection B is this region. right? This region intersection union with C complement the region that is outside of C, the whole other than C. So that is the shaded region other than this set C. Question number 3, part 1. Write the standard form of a quadratic equation in the form, the vertex form, where a, b are constants, right? So the standard form is minus x square plus 7x plus 8, right? So the first step is we have to take the coefficient of x square common from the first term and the second term. So we have x square minus 7x and the third term is stay the same. Now, in the next step, we have to take the coefficient of x, that is negative 7, divided by 2 and take its whole square. Right, so this is 49 by 4. So we add 49 by 4 and subtract 49 by 4 inside the bracket. So minus 1 is outside, x square minus 7x plus 49 by 4 minus 49 by 4 and positive 8 is outside. Right, now complete the square. We have to combine the first three terms, x square minus 7x plus 49 by 4, and taking negative term outside, negative times negative is positive 49 by 4 plus 8, right? So this is negative and we have to complete the square. So x square and 49 by 7 square by 2 square, so at a negative sign. So we have x minus 7 by 2 whole square, right? And the term over here is 49 divides 4 plus 8. This is 81 by 4. So plus 81 divides 4. Now let me rewrite it into the given form. So we can say that now a minus, so a is 81 by 4 minus x minus b. So x minus 7 by 2 whole square, right? Now for the second part, hence state the maximum value of this function and the value of x at which it occurs. Okay, so the maximum value is, we have the vertex. The coordinates of the vertex are, these are the coordinates of the vertex, right? So the coordinates of vertex are 7 by 2 and 81 by 4. So this is x coordinate and this is a y coordinate. So we can say that the maximum value of the function is 81 by 4 and at x is equals to 7 by 2, right? Now for part 3, using your answer to part 1 or otherwise solve the equation, right? So we have this equation, 8 plus 7z square minus z power 4 equals to 0. So if I compare with the given one, we have 8 plus 7x minus x square equals to 0. So it means we have x is equals to z square, right? So the answer of this expression, this vertex form we have is 81 by 4 minus x minus 7 by 2 whole square equals to 0. Now in terms of x, we have to use z square here, right? So we can say 81 by 4 minus z square minus 7 by 2 whole square equals to 0, right? So z square minus 7 by 2 whole square equals to 81 by 4, right? Shift this on the other side. Okay, now taking square root on both sides. So we have z square minus 7 by 2 and square root of 81 is 9. Square root of 81 is 9 and square root of 4 is 2. So this is plus minus 9 by 2. Right, now we have two values for z square here. So we can say z square minus 7 by 2 is equals to 9 by 2. Right, so from here z square equals to 9 by 2 plus 7 by 2. So 9 plus 7 divides 2 is 8. So z square equals to 8, and the value of z is equals to plus minus square root of 8. Right, this is the first value. Now let me find the second solution over here. So the second is z square minus 7 by 2 equals to negative 9 by 2. So z square equals to minus 9 by 2 and minus plus 7 by 2. So z square equals to 9 minus 7. This is 2 divides 2. This is equals to 1. So z equals to plus minus square root of 1, or just we can say that z equals to 1. So this is negative 2 and negative 1, and square root of minus 1 does not exist. So the only solution is plus minus square root of 8. Question number 4, we have given the second derivative number 1, find dy by dx, given that dy by dx equals to 1 when x is equals to 1. So let me rewrite this. So we have 2x plus 3 and x plus 1, its power is negative 4, right? So we have to integrate it. d2y over dx square, integration with respect to dx, equals to 2 is outside, integration of x dx, plus 3 is outside, integration of x plus 1 power minus 4 dx. Right, so here we have dy by dx. This is equals to 2, x integration is x square by 2, plus 3, we have x plus 1, we have to use a power rule, minus 4 plus 1 divides minus 4 plus 1 plus some constant of integration. Right, to find the constant of integration we have to use this condition that the derivative is 1 when x equals to 1. So let me rewrite this. Dy by dx equals to, cancel the 2, we have x square, right? This is negative 3. Now this negative 3 and this is cancelled, so we have minus 1 over x plus 1 power is 3 plus c. Now let me substitute the condition. The derivative is 1 at x is equals to 1. 1 minus 1 by 2 cube plus c, right? Okay, now we have 1 minus 1 plus 1 by 8 equals to c. So c value is just 1 by 8. So let me rewrite the curve. From here, the first derivative dy by dx is equals to x square minus 1 over x plus 1 whole cube plus 1 by 8. Right. Now for the second part, find y in terms of x, given that y is 3 when x equals to 1. Right. So again, we have to integrate it. So integration of dy by dx with respect to dx, integration of x square dx minus integration of x plus 1 power minus 3 dx plus 1 by 8 is outside, integration of 1 dx. Right. Further simplification, we have y equals to x cube over 3 minus x plus 1, its power is minus 3 plus 1, so minus 2 over minus 2 plus 1 by 8 x plus some constant of integration. Let's say d is a constant of integration this time. Okay, now substituting the condition that y value is 3 when x is 1. So we have 3 here, 1 by 3 minus minus plus. We have 1 by 2. This is also down. 1 plus 1 square plus 1 by 8 plus d. Right. So 3 minus 1 by 3 minus 1 divides 1 plus 1 is 2 and 2 square is 4 and 4 times 2 is 8. And minus 1 by 8. This is equals to the d. Right. Let me simplify. 3 minus 1 by 3 minus 1 by 8 minus 1 by 8. This is equals to 29 by 12. So the d is 29 by 12. So the curve y is equals to x cube over 3 plus 1 by 2 x plus 1 whole square plus x by 8 plus 29 by 12. Question number 5, given that matrix A equals to this and matrix B equals to this, number 1, find A inverse. Okay, so A inverse equals to adjoint of A divides the determinant of A, right? So first let me solve the determinant of A. Determinant of the matrix is 2 times 4 is 8 minus 1 times 3 is 3, so this is equals to 5. So we have 1 by 5. Here we change the positions, 2 and 4 become 4, 2, and changing the sign of 3 and 1, minus 3 and minus 1, right? Now for second part, the matrix C is such that C times A equals to B. So we can say C times of A, doing A inverse here, equals to B times of A inverse. A inverse is identity matrix, so C equals to B times of A inverse. So C equals to matrix B we have given is 1, minus 2, 4, 5, and A inverse is 1 by 5, 4 minus 1, minus 3 and 2. Okay, now let me simplify. We have C equals to 1 by 5 is outside. Rows are going to multiply with the column. 1 times 4 is 4. 4 times minus 1 is 4, right? 1 times minus 3. 4 times 2 is 8. 2 times 4 is negative 8. And 5 times minus 1 is minus 5. 2 times 3 is positive 6. And 5 times 2 is 10, right? So the matrix C is 1 by 5. We have 0 here. 8 minus 5, minus 8 minus 5 is minus 13. And 8 take away 3 is 5. And 6 plus 10 is 16. So this is a matrix C. Now for part 3, find the matrix D such that A inverse D plus B equals to I. So from here we can say that A inverse D equals to I minus the matrix B. And further simplification, we can say A times A inverse B D equals to A times of I minus B. A inverse is identity matrix, so we can say the matrix D is A times I minus B. So we have a matrix A that is 2, 1, 3, 4. And its times by identity matrix 1, 0, 0, 1 is 2 cross 2 matrix identity matrix, and matrix B is 1, minus 2 and 4, 5. Okay, so D is equals to 2, 1, 3, 4, and from here 1 minus 1 is 0, this is minus 4, this is 2, and this is 1 minus 5 is minus 4. Okay, now the product of the two matrix is 2 times 0, 3 times 2, this is equals to 6. 2 times minus 4 is minus 8, and 3 times negative 12. 3 times 4 is 12, minus 12. 1 times 0, 4 times 2. 1 times minus 4. 4 times 4 is minus 16, right? For the simplification, the matrix D is 6, 8, and minus 20. And here we have negative 20. So this is a matrix D. Question number 6, solve the simultaneous equations. So let me convert this logarithmic equation into exponential form. So we can say x plus 2y is equals to 2 power 3. So this is equals to 8. And from here we can say log base 2. We have a difference. So 3x divides y equals to 1. And we have 3x over y equals to 2 power 1. This is equals to 2, right? So let me rewrite the two equations. We have x plus 2y equals to 8. This is my first equation, and the second, from first we can solve for x, that is 8 minus 2y, right? And my second equation is 3x equals to 2y equals to 3x, we can say, because just multiplying by y, right? So substitute that x value into this equation. So 2y equals to 3 times of x is 8 minus 2y. So 2y equals to 3 times 8 is 24, minus 3 times 2 is 6y. So 2y and minus 6 plus 6y equals to 24. So 6 plus 2 is 8y. This is equals to 24. And y equals to 8 times 3 is 24, right? Now let me solve for x. So x is equals to 8 minus 2 times of the y value. 8 minus 6. So x is equals to 2. So x is 2 and y is 3. Question number 7. A squad of 20 boys, which include 2 sets of twins, is available for selection for a cricket team of 11 players. Calculate the number of different teams that can be selected if, number 1, there is no restriction. So if there is no restriction from the total, we have to choose 11 player, the team of 11. Okay, so 20 C11. This is 167960. Okay, now for the second part, both sets of twins are selected. Okay, so let me break this down. So from the total 20, we can say that we have 2 twins, first set of 2 twins, and then we have again 2 twins, and the remaining we have 2 plus 2 and then 16 makes a total 20, right? Okay, then the question is both set of twins are selected, right? So from the first set of twins means from 2 we have to select 2 times, from the other set 2 we have to select 2 times the remaining is 16, we have to select how many? 11. So 11 minus 4, 11 minus 4, that is 7 are left, because the total we have to select are 11. 7 plus 2 is 11, right? Okay, so 2 C2 times 2 C2 times 16 C7. This is 11440. Right. Now for the third part, one set of twin is selected, but neither set twin from the other set is selected, right? So again, let me break this down from the 20. We have a set of twin, that is 2 twins from set A. We have 2 twins of set B, and the remaining we have 16 people, right? So one set of twin is selected, means one twin is selected from the first set and one twin is selected from the second set, but neither twin from the other set is selected, right? So in this question we have to do 2 cases here, right? So for case 1, we can say one set of twin is selected. So if I select the set the twins of set A, so 2C2 is selected and the remaining we have 16C9, because the total we need is 11. Now for case 2, we can say, let's say the set B, the 2 twins of set B we are selecting, because one set is selected. So 2C2 is selected and 16C9, right? Now let me simplify this. 2C2 times 16C9. 11440. This is 11440 plus this is also 11440, and the total we have plus 11440. This is 22880 number of ways, right? Now for the fourth part, exactly one twin from each set of twins is selected, right? So again, if I draw from the 20 people, we have 2 twins of set A, we have 2 twins of set B, and the remaining people are 16. And the question is exactly one twin from each set of twins is selected. Means from the first set of twins, from 2, we have to select one twin, times from the other set we have to select one twin, times we have the remaining one. So from 16 we have to select 9, because the total we have to make 11, right? So 2C1 times 2C1 times 16C9. This is 45760. 45760 number of ways. Question number 8. Variables x and y are such that when y square is plotted against e power 2x, a straight line is obtained which passes through the points 1.5 and 5.5, 3.7 and 12.1. Find number 1 y in terms of e power 2x. So a straight line, so we know that the straight line is y equals to mx plus c, right? So in this case, we have y is y square and x is 2 power e power 2x. So we can say y square equals to m e power 2x plus c. Now we have to substitute the 2 points, right? This first is your x e power 2x coordinate and the second is your y square coordinate, right? Now substituting the first point is 5.5 equals to m times 1.5 plus c. The second point is 12.1 equals to m times of 3.7 plus c, right? Now let me subtract the two equations to get rid of c and solve for m, right? So subtraction, we can cancel the c, subtraction here and subtraction here, right? So here we have 5.5 minus 12.1. So this is equals to 6.6, negative 6.6. And for m, 1.5 minus 3.7. This is minus 2.2. Now 6.6 divides 2.2, m value is 3. So m equals to 3. So now substitute the m value into the first or second equation to get c, right? So we have c from the first equation is 5.5 minus 1.5 times m. I mean c, 3, sorry. So 3 times minus 1.5 and add 5.5. This is c. C is equals to 1, right? Let me rewrite this equation. So we have the equation is y square equals to m is 3 e power 2x plus 1. We have to find y in terms of e power 2x plus 1, right? So to get y, we have to do the square root plus minus square root of 3 e power 2x plus 1. This is y in terms of e power 2x, right? Now for the second part, find the value of y when x is equals to 3. So just substitute x equals to 3. We will get the two values of y. So y equals to plus minus. We have a square root of 3 e power 2 times 3 is 6 plus 1. Let me simplify this, right? So e power 6 times 3 plus 1 and square root of answer. This is 34.8. So y equals to plus minus 34.8. Right. Now for the third part, the value of x when y equals to 50. So just substitute y equals to 50 and solve for x. So y is 50. This is equals to plus minus square root 3 e power 2x plus 1. Okay, to get rid of square root, we have to do squaring on both sides. So 50 square is 2500. So 2500. This is equals to 3 e power 2x minus 1. Or we have 3 e power 2x equals to, shifting this on the other side, 2500 plus 1. Sorry, this is already plus. We have minus 1. Right. And e power 2x equals to, this is subtract 1 and dividing by 3, 833. Now taking natural log on both sides. So 2x natural log of e equals to natural log of 833. And natural log of e is just 1. So x is equals to 1 by 2 natural log of 833. Okay, so natural log of 833 divided by 2, we have 3.36. X is equals to 3.36. Question number 9, part A. Solve this equation for x is between 0 to pi radians. Right, so let me suppose that theta is equals to x plus pi by 4. Right, so we have equation sine 2 sine theta equals to square root of 3 and sine theta equals to square root of 3 divided by 2 and theta equals to sine inverse of square root of 3 divided by 2. It is in radians, right? So let me convert my calculator into radians first and now find sine inverse of square root of 3 and divided by 2. So pi by 3, right? So theta equals to pi by 3, right? And we know that between 0 to pi, sine is positive in first and second quadrant. So for second quadrant, we do pi minus theta. So we do pi, pi minus pi by 3, 2 pi by 3. The second answer is 2 pi by 3. So we have two values of theta. Let me substitute it back to get the x values, right? So to get x, we have to subtract pi by 4 from theta. So x is equals to theta minus pi by 4. So pi by 3 minus pi by 4, 1 by 3 minus 1 by 4. This is pi by 12. And x is equals to 2 pi by 3 minus pi by 4. So we can say 2 by 3 minus 1 by 4, 5 pi by 12. And these two values belongs to the domain that is between 0 to pi radians. Now for the second part, solve this equation for x is between 0 to 360 degrees. Okay, so let me simplify it first. Sine 3 secant is 1 by cos y equals to 4 cosecant is 1 by sine y. So cross multiplication, we have sine y over cos y. Sine is over here. This is 4 by 3. And sine by cos is tangent y. This is 4 by 3. So from y, we have tangent inverse of 4 by 3. Right. So let me solve this in degrees. Convert it into degrees. And do tangent inverse of 4 divides 3. We have 53.13 degrees. So y equals to 53.1, right? So the domain is between 0 to 360. So tangent is positive. So it is positive in the first and in the third quadrant. So for the third quadrant, we have the y value that is 180 plus that answer. So plus 180, we have 233.13. So 233.1 degrees. So these are the two values of y that satisfies the domain. Now for part C, we have to solve this for z is between 0 to 360 degree. So let me rewrite z. Cot is cos t, cos z over sin z, minus tan is sine by cos, and 2, and cosecant is 1 by sine, right? Okay, let me take LCM. So we have cos square z minus sine square z divides cos z sin z equals to 2 by sin z. We can cancel sin z, cos square z, and minus sin square z. Now we have 7 cos square z minus sin square z equals to 2 times of cos z, right? Okay, now let me convert throughout the equation. Is this cos, convert this into cos. So 7 cos square z minus, we know that cos square theta plus sin square theta is equals to 1. And if we have to find minus sin square theta, we have cos square theta minus 1 is minus sin square theta, right? Minus sin square theta is cos square z minus 1. This is 2 cos z, right? And we have the equation 2, right? We have to add it. So we have 7 and we add 2 cos square z minus 1 equals to 2 cos z, right? Sorry, I did the mistake here. 7 is just multiplying with cot z, not with the whole bracket. So 7 is with this term only, or not outside. So 7 is with this term, 7 is over here, not outside. So 7 plus 1, this is 8, right? So we have 8 cos square z minus 2 cos z minus 1 equals to 0, right? Now let me factorize this. 8 times minus 1 is minus 8, and 2 times minus 4 is minus 8, and 2 minus 4 is minus 2. Cos scale z, and 4, 2 minus 4, yes, plus 2 cos z minus 4 cos z minus 1 equals to 0. So let me take 2 and cos z common. So times 4 is 8 cos z plus 1. Negative 1 is common, 4 cos z plus 1 equals to 0, right? The two factors are 4 cos of z plus 1, and we have 2 cos z minus 1. This is equals to 0. Let me put both the factors separately. Equals to 0. From here 4 cos z plus 1 equals to 0, and 2 cos z minus 1 equals to 0. So cos of z is equals to minus 1 by 4, and from here cos of z equals to 1 by 2, right? So let me solve for z. So from here we have z equals to cos inverse of, let me do for the positive, and then we can solve the two z values in the negative when the cos is negative. So it is in degrees, my calculator is in degrees, so cos inverse 1 divides 4 is 75.5, or yes, 75.5. So we can say z is equals to 75.5, right? And let me solve this. Z is equals to cos inverse of half. This is 60, so z equals to 60. Okay, let me draw the coordinate and check on which quadrant cos is positive and negative. Okay, so we have A, S, T, C. Here we have theta 180 minus theta 180 plus theta and 360 minus theta, right? Now for the first we have cos is negative. Cos is negative in second and third quadrant. So 180 minus that z value and 180 plus the z value, right? So if we do 180 minus 75.5, we have 104.5, and cos is negative in the third as well. So 180 plus 75.5, this is equals to 255.5 degrees. Now cos is positive in the first and in the fourth quadrant. So 60 is in the first quadrant. Now for fourth quadrant, z equals to 360 minus 60, that this is just 300, right? So these are the four values of z that belongs to the domain between 0 to 360. Question number 10, the equation of the curve is given for x is greater than equals to negative 3. Number 1, find dy by dx, right? So here we have to apply the product rule, right? So dy by dx is equals to, the first function is x square. We have to find the derivative of second function, x plus 3 power is 1 by 2, plus the second function is as it is, and the derivative of the first function, x square, right? So here we have x square. We have to apply the power rule. 1 by 2 square root of 3 plus x, and the derivative of 3 plus x is just 1, plus square root of 3 plus x, and it's 2x. Further simplification, we have x square divides 2 square root of 3 plus x, and plus 2x into square root of 3 plus x, right? Now for the second part, find the equation of tangent to the curve at a point where x is equals to 1, right? So equation of tangent to the curve, we need the point. So y is equals to, when x is equals to 1, so we have 1 square root of 3 plus 1. 1 square is 1, square root of 3 plus 1 is 4. This is equals to 2. So we have xy is equals to 1 and 2, right? And we have to find the m value. M at x is equals to 1. So m is dy by dx at x is equals to 1. So we have dy by dx from the first step. So this is equals to at x is equals to 1, so we have 1 over 2 square root of 4 plus 2 square root of 4, right? So square root of 4 is 2 and 2 times 2 is 4, so 1 divided by 2 times 2 plus 2 times 2, right? So we have m is equals to 1 by 4 plus 4. 1 by 4 plus 4 is 17 by 4. Right. Now let me write down the equation of tangent. So the equation of tangent is y minus y naught equals to m into x minus x naught. So y minus y naught is a 0.2, m is 17 by 4, and x minus x naught is the 0.1, right? Or if I can further simplify, y equals to 17 by 4 x minus 17 by 4 and plus 2. So 17 by 4 times minus 1 and then plus 2. This is minus 9 by 4. So y equals to 17 by 4x minus 9 by 4. This is the equation of tangent. Now for part 3, find the coordinates of the turning points of the curve. Turning points are the stationary points and turning points or stationary points, we have to put the gradient dy by dx is equals to 0, right? So we have the value of dy by dx from the first part. We have to put it equals to 0. Let me put this equals to 0 and solve for x, right? So we have the derivative x square divides 2 square root of 3 plus x plus 2x square root of 3 plus x. This is equals to 0, right? Further simplification, shifting this term on the other, we have to find the coordinates, means we have to find the x and the y values, right? So x square divides 2 square root of 3 plus x is equals to minus 2x square root of 3 plus x. Now we have to do the cross multiplication. So here we have x square and here we have 2 times 2 is negative 4x, and square root times square root is just this term 3 plus x. Further simplification, x square equals to minus 4x square and minus 12x, right? Shifting the terms to the left, x square plus 4x plus x square plus 12x equals to 0. So we have 5x square plus 12x equals to 0. So taking x common, we have 5x plus 12 equals to 0. So here we have x is equals to 0 and 5x plus 12 equals to 0. And from here x is equals to minus 12 over 5. Let me simplify. Negative 12 divides 5. This is negative 2.4. Now let me find the corresponding y values by substituting into the given curve. This is my given curve 1 by 1, right? At x is equals to 0, we have y equals to 0, right? At x is equals to negative 2.4, y equals to minus 2.4 whole square root of 3 minus 2.4, right? So 3 minus 2.4 and square root of answer and times 2.4 times 2.4. We have 4.46. Right, now let me find the coordinates of the stationary points. So the coordinates of the stationary points are xy coordinate. The first is 0, 0 and the other is minus 2.4 is the x and the y is 4.46. Question number 11, a line with equation this is tangent to the curve with equation this. Means line is tangent to the curve. It means line touch the curve at one point. Number 1, find the two possible values of k. So line touch the curve. So put them equal. So we can say 7 minus kx minus x square equals to minus 5x plus k plus 5. So we can say 7 minus kx minus x square plus 5x minus k minus 5 equals to 0. So negative x square, and the x terms are, these two are the x terms, k minus plus 5 minus k is the x terms, and the constant terms are minus k and 7 take away 5 is 2 plus 2. This is equals to 0. Okay, so or let me divide throughout by negative. So x square plus k minus 5 times x plus, we can say, k minus 2 equals to 0. So it touched the curve at exactly 1 point. So it means the discriminant is equals to 0. So this is a quadratic equation. So its discriminant is equals to 0. Right. Now let me solve the discriminant, that is b square minus 4ac. This is equals to 0. Right. So what is the b? B is k minus 5 its whole square minus 4 times the a value times the c value. This is equals to 0. So we have k square minus 10k plus 25 and minus 4k and plus 4 times 2 is 8. This is equals to 0. K square. Okay, now the k terms are minus 10 and minus 4. So minus 14k, and constants are 25 plus 8, 33 equals to 0. Right. Now this is a quadratic equation and a variable k. We have to factorize it. So let me do the factorization over here. Okay, 1 times 33 is 33, and we can do 11 times 33 33, and 11 times 3, and 11 minus 11 minus 3 is minus 14. Yes, so k square minus 11k minus 3k plus 33 is equals to 0. K is common, k minus 11, negative 3 is common, k minus 11, this is equals to 0. So the factors are k minus 11 and k minus 3. This is equals to 0. So the two possible values of k are k is equals to 11 and k is equals to 3. These are the two possible values of k. Now for the second part, find for each of your values of k. For each of the values of k, so we have two k values, 3 and 11. The equation of tangent. We have given the equation of tangent is this. So let me find the equation of tangent first. So the equation of tangent, right, so the first equation of tangent is when k is equals to 3 and then when k equals to 11, right? So k is equals to 3, we have the equation of tangent is y is equals to minus 5x plus 3 plus 5. So from here y is equals to minus 5x plus 8. This is my first equation of tangent, right? Now for k is equals to 11, the equation of tangent is y equals to minus 5x plus k plus 5. So from here y equals to minus 5x plus 16. These are the two equations of tangents, and the equation of the curve. So this is equation of curve. So just put the k values. We will get the two equations of curve, right? Okay, so I can say that the equation of curve right. So the first equation of curve is when k equals to 3. We have the equation of curve is equals to y is 7 minus kx, 3x minus x square, and when k is 11, so the equation of tangent is equation of curve is y equals to 7 minus kx, so minus 11x minus x square. right? And the third part is the coordinates of the point of contact of tangent and the curve. So when tangent intersect the curve, so for k equals to 3, this is a tangent and this is a curve, so their point of intersection. And for k equals to 11, the tangent and the curve point of intersection we have to find. Okay, so for the first, the equation of tangent and the curve, number 1, as you can see, we are doing for k equals to 3, the first case. This is a tangent, this is equation of tangent for 3, and this is equation of curve for 3. We have to find the coordinates of points of contact of tangent and curve, right? So the first, k equals to 3, right? So the tangent and the curve. So we have 7 minus 3x minus x square equals to minus 5x plus 8, right? So from here, minus x square minus 3x plus 5x plus 7 minus 8 equals to 0. So minus x square plus 2x minus 1 equals to 0. Taking negative sign common, x square plus negative 2x plus 1 equals to 0. So this is x minus 1 whole square equals to 0, right? So we have two values of x from here. So taking square root, okay, taking square root, we have x minus 1 equals to 0. So x is equals to 1. So when x is equals to 1, what is y? So let me solve for y. Y is equals to minus 5 times 1 plus 8. So y is equals to 3, right? So when k equals to 3, the coordinates of points of in contact of tangent and curve is 1 and 3. Right, now let me do the second case. Now for case 2, when k equals to 11, the equation of tangent is minus 5x plus 16. This is equals to the equation of curve, that is 7 minus 11x minus x square. Okay, so minus 5x plus 16 minus 7 plus 11x and plus x square, this is equals to 0. So we have x square, and the x terms are 11, take away 5. 11 minus 5 is 6x, and the constant is 16 minus 7 is 9, plus 9, this is equals to 0. So this is x plus 3 whole square. Taking square root, x plus 3 equals to 0. So x is equals to negative 3. Now let me find the corresponding y value by putting the x value into equation of tangent. So y equals to minus 5 times minus 3 plus 16. So y equals to 3 times 5 is 15 plus 16, right? So 15 plus 16 is 31. So y equals to 31. So when k equals to 11, the points of the coordinates of points of contact of tangent and the curve are negative 3 and 31. Now for this third part, find the distance between the 2 points of contact. So the 2 points of contacts are 1, 3, when k is 3, and when k is 11, they are minus 3 and 31. So we have to find the distance between the 2 points, right? So we can say that the distance is square root of x2 minus x1 whole square. X2 is minus 3 minus 1 whole square plus y2 minus y1 whole square, and taking its square root. So this is square root negative 4 whole square plus 31 subtract 3 is 28. 28 whole square, right? So square root of 14 square is 4 times 4 is 16. And what is 28 square? 784. Square root 784 plus 16 is square root of 800. This is the distance between the 2 points of contact, right? So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.